for coming. I know it's the last day after lunch, prime time. Everybody's dying. Everybody's tired. The party yesterday was fine. And this will be a very technical lecture. I'm telling you in advance. I'll show you, uh, uh, I'm going to show you a lot of code written in Go. It doesn't matter what is the language. It's valid for any system. My name is Hugo. For those of you who don't know me, I've been working for Digital for 3 years, and I am in a team that handles all the accounts and productivity. I'm here to talk to you about the way we structured our tests, our context, and hope that you may benefit from this. The context that I'm talking to you about is microservices. What is microservices? Minor services, requests, responses. Somebody makes the call, expects an answer, which may or may not have dependencies because most of the services have something upon which you depend, database or any other service. However, this is the context. The test pyramid. Who knows the test pyramid? Good. Everybody knows that the test pyramid, many unit tests, quick and small, integration tests, and very few. There's so few that you can't read them. User tests or acceptance tests. Okay, everybody's fine with the definition. Why does the test pyramid exist? Who knows? No? Come on, folks. Test pyramids. Why do we run test pyramids? Because unit tests are fine, quick, easy to write, but they don't tackle any of the problems. Most programs are integration problems. So I write the test, it helps in development, but to tackle the real problems, that is the unit test. Very good. So we want integration tests, but they are slower in general. And when there's a problem, you don't know that a problem appeared. You don't know whether it happened because of unit X or unit Y. So you have to debug it and understand why it went wrong. And acceptance tests or user tests are the coolest because that is exactly what your customer, your user will experiment or see, what the person will feel. So the closer you are to this, the more chance you will have to ensure your system will behave as you want it to behave. Howsoever they exercise everything, and in general they become unreliable because X broke down, because it had nothing to do with my test. I'm going to run it again. Let me run it again, so perhaps this will pass. It will pass this time. So there's much of this kind of problem. What are the problems that we found? Just a small pause. I am very much with Woody's idea as presented on the first day. Let me tell you what we are doing. It doesn't mean that you have to do it, nor that my problem are your problems. If you have these problems, all well and good. But if you don't, ignore what I'm saying and move over to the next. The problems that we found is that our unit tests were very simple, but they were very hard to write, laborious in writing and maintaining, and they didn't tackle many problems. Our integration tests ended up repeating much of the logic of unit tests because I want to know that when I pass value X, it will hit a function that will call something else, and there will be no problem to convey this value as a result to this other thing that I'm integrating. So we had to repeat several cases that were at the unit level in the integration test. So we ended up creating code and then throwing it away for things that didn't work out or nor brought or added any value. In general, our acceptance tests were very few indeed. And that little letter there, small letter, small print, I had acceptance tests only for very few things when everything came out right. When somebody gave me a right value at the right field that I wanted. Well, but what if it did pass? What if it didn't pass? No. Oh, unit or integration, I never passed in case of unexpected, in quotes, by my acceptance test. And it happened in our APIs and our behaviors when you came to not to the not ideal case that they broke down and changed. That broke other integrations. We found all these problems and we sought a solution. Which solution, as we found, was the injection of dependencies. Who knows what this is? Good. This is it. I'm over. Thank you for your presence. Use injection of dependency injection in your testing, and it's up to you to solve the problem. Oh, good? No? Well. So, injection of dependencies. Now I'll show you a lot of code. I'll ask our volunteers to hold microphones because I will suspect that somebody will have questions. And if you have any questions, please ask. I'll stop for a minute. Please don't mind the code specifically because, as I said, it's Go, but it's what we because we use this at the company today. What you have to keep in mind is that code means testing means codes that depend on the code that you're testing to give you a result. All is well or all is not well. Does everybody concur? Good. Slides will be available. You can click on this link. You don't have to write it down nor learn it by heart. All the codes I'll show are there, nice and pretty and separated, and you can see all the slides and see the growth of the code because I'm going to set it up with you from the early beginning, an application with the injection of dependencies where I don't have to have unit tests, integration tests, or acceptance tests. But all this is a lie. I do have them, but I don't, not in the way that serves us here. So, starters, can you read this? A little, more or less? No? Not at all. More simple, I'll create an HTTP server. This is the entry function. Create a new server and run it at the door that I gave you, right? At the port I gave you. This is not testable. It will run and there's nothing you can do. Let's use the server, the server's new HTTP, to be whatever it is we want to test. What is this server? It is basically an object. And I use this Lux library. It has to do with mapping routes for you. You give me a string and I will determine what function will be called. And I will begin with this. If you called, I'm going to have a hello world. Hello world will simply respond hello world. There's that print right on the middle that I'll explain to you why it is there. Good. How do I test this thing? A unit test. I create a server, and in fact I have a function, my hello world function. I call that function here, and I pass something here that HTTP test will only record the answer. Whatever it is that you wanted to that it respond, it's like a SPI. For those who know what SPI is, this is a SPI. And I run my test. I say I have to return 200, and I have to say hello world. Is this a good unit test? Yes? Good. The problem is that I'm testing the function. When I backtrack to the code, I'm not testing anything at all here. I'm testing these 3 lines only. Obviously, if I do nonsense in any of the others, my test will run zilch. How do I test this? So, I will now create a server for that object, HTTP, server HTTP, and call it. There's a bit of a problem because the way that this thing works is the only method that I have available here is the server HTTP. which will exactly use the library. And given a request, what is the pathway? What do I have to call as a function? I call the function, I take the answer, and that's it.
which is the work the library does. So that's great. I go there, I create my server, I create my request object I'm waiting for, which is simply about get slash the new there at the end. New, for those who know how it works, just saying that there's nothing in the body. I have nothing else to pass. It is just a get. And then I do the same thing that I was doing before. It is not that complicated because it doesn't really matter, as a matter of fact, because if it's difficult to read, it's because it's not important anyway. So great, now that I have this, I am testing the library, but I have no idea whatsoever whether or not I can deal with that. Well, if if a true HTTP request comes up, HTTP 1.0 get that, etc., that really goes from the browser to your server, I don't know if this will work. Should it come? Well, okay, how do I test for this then? Well, I am already coming at the level where of the acceptance test, right? I am slowly but surely moving in this direction, right? So let's test this up. Well, it's a bit more hard work now because now I have to go there. I have to open a door, right? I have to open a door. I need something to be available for you to be able to make a request there, and then say, well, start the server there. In a case here, it is something that creates a thread. So it is something that is running there. It is the same process, but not the same line of execution, right? And then I say, well, at the end, just close this up, and then I go there and I say, well, I'm doing a true request now. If you have you noticed here I was using this HTTP test, so it is not a true request. It is only the library giving me a way to do a test version of that. And now I am doing a true request. This is how I would run a true request for an external job. The same thing I would do here. All right, then I do the other things that I was doing before. I take the answer here. I take the answer taking an HTTP client, a standard library. I do the call for that address that I have just created. So in the case here, it will be a local host 32,785 something one, some door that had been available, and then I do the call. Then I make the call. Well, for you, is this unit integration or acceptance? Who thinks it's a unit? Please raise your hand. Who thinks it's integration? Who thinks it's acceptance? Does it make any difference? No, it doesn't. So if the test runs, for me, but it doesn't really matter. All right, so it tests everything. It goes up to the server, the code is executed and closes down. It is basically like doing this manually. I go there, get the server at hand, I go there, do an HTTP request in the browser, I receive the response and say, okay, good, and then I leave, right? Well, okay, I am very close to what the user would do, right? So let's go there. Let's do this better because, as a matter of fact, if you look at these two functions here, that it's hard to see. But anyway, the one on top here was the first version we ran here with the object, and the one below here is this most recent where I create a server and I make a true request to that server. Okay? Now these parts here, all of them, these parts are very similar to one another, right? So it is basically all the assertions and whatever I am testing. I want to set up a request and pass it on to what I'm going to test, and that's it. So now let's refactor then. Well, we can't read, and you shouldn't be able to read anyway. I just separated here the beginning, which is different for each one of these functions, from the part below, which is not different. The part that became more different is the first test that I had, which is this part on top here. Now this is truly different from this here. Well, let's have a true get here, and then a true, right? So, and then I go there and I separate this and I write a function that I call make request. So I put here, I make the request, right? Well, much similar. Now I can extract this all. You can't read and it doesn't matter. I'm just telling you, we'll have here a server in memory that does what was only to create the object and make the call. And here, down here, I don't have to do anything. But thus I create the server and make the call. So can you see that this is basically the same test? The only thing I'm doing is that I'm changing the beginning. So if I do this, I can refactor and say I'm just injecting dependence in my test. I create a function saying one, the dependencies there are, regardless of how they are, run the test. And this is what I do here. And I discover, well, if I want to run in the unit mode between quotation marks, I go there, I create the object, and I pass the object as being the thing that I will use to test. If I want to run here in this integration mode, I go there, I upload it to the server and give you the address for the server, right? Okay? And then I say, well, go there and run the test. Now I can delete those two methods were very similar. Now I can make them have only one method. I just say, well, with all the dependencies that we have here, go there and run my test. The way I did this so far, basically now I only have one test code, but I can run it locally and nothing else. There's no process going up, absolutely nothing else running in my computer. I can just say run the test, and it creates everything in the memory, executes there, and gives me the result. But I can also say, well, if I am already in this situation here, why can I run the test here and see that, look, here I ran it here, the unit 1, it worked. I saw here, I ran the other one, it worked, but I only have one test code, right? Now that I have this, I can say, well, now I can test it against something outside, because it doesn't really make any difference what I'm testing here. So, great. Then I will say, if I am running with a past address, it is basically that idea of factory apps. You know, if my environment is XYZ variables, I will run this, I will connect to this database and do this and do that. You know that, right? Well, let me know. Do you all know what I'm talking about here? The call factor X? Do you all know what that is? So this is basically what I'm doing with my test here. I'm saying, well, if I have there an address to hit, well, hit that address. If I don't have an address to hit, you know, it goes to the memory. And then now I can run against my local server that I started to run here. I just went there in another space in my terminal, run the server here. I know it is running in door 8080, and I run a test here. It is the same test that I gained. I trust in the server that I was developing. I ran it with integration, and I noticed that all my integrations were working, and now I know that my external process, my outside process, has the behavior that I want it to have. And the same thing I can do this here with a true external process. This is all in New York, and some machine there I don't even know, because, you know, today a droplet went up there. I asked it to run in the server, and it's running there. But anyhow, I can run it there, and I know that it continues behaving as I want it to behave. Has it made any sense to you so far? Does it look good, people? What do you think? Would anyone have any thing else, any question? I don't know, anything to add, any issue with this? All right, good then. Same code running in local memory, remote, whatever it is. From the viewpoint of having to maintain my test suite, I cut my maintenance test by 3, and I didn't lose anything as far as execution cost is concerned. Now we have no questions. All right, good. You would say, well, Hugo, this is very easy. You were just testing something. Basically, it is a function, right? You receive the input, you do nothing with it. It is only your GET request and you answer. But a true service always has a dependence. Then what do you do when you have a dependence? Well, I took the database here because the database is the most common dependence that we have, right? Okay. So I went there and I said, well, the factor X, as always, I take my database and I say, well, if I have here the address of the database collection, well, the clicker stopped working here. But anyhow, So and then I create a connection with this database. If there's no address, I will presume I'm running it in development. So and actually, when you truly run this, you say, well, if there is no introduction, it's a fault now because that shouldn't happen. But this for ours, just our example here, I leave it at this, and I'll say, great. And my server now needs my server now needs this database repository to work because I will use it later on. Now, when I make this change, I have just broken all our tests, right? Well, good. So, how do I solve our test here? Well, first, how do I solve my own server? The own server, simply I will receive this repository, and then I will need an object that will be able to help me use this repository when I use it, so when I need it. So I introduce the HTTP handler, which is actually what will have all the functions that I will serve. Actually, this is the guy, this is the man that has all the logic that the server should have. Now I will correct the tests. Well, in the unit test, I now have an object that I am testing instead of only a function. So I go there, create an HTTPM. I don't have to move anything into there because I'm not using the database anyway. And I am making the same call that I was doing before, right? Very easy, okay? Good. Now, integration is a bit more complicated because I need to create something that is real. So what do I do with the unit test in general when I need something that is not, for example, when I have some dependence and I don't want any to use any real thing, mock, sub, spy, something of this sort. In my case, I will use a stub here. The stub is simply, well, I can tell you what you have to answer me when a call comes up, right? Okay, so I do this. I'll use the server in the memory that I had there, but now I will pass it into a database, which is actually a map, a string-to-string map. And then if you ask for something, I answer what is coming there. And then in the next one, when I am thinking and while I'm running this integration test, I want to execute more things. I would like to test this, for instance, that if whether my queries are correct. So that's great. How do I do this? Well, Rails answered this for us 15 years ago. You put a light cycle there, and that's it. So I'll do that. I will create a memory database using the cycle light. I will inject this in the server. Easy. I create then a new database and I say, well, create a cycle light there, use the memory address so I don't have even to use it, and say, well, answer with this, whichever query it runs will run as if it would run if I had a true unit according to my cycle leg, right? The cycle leg. All right, so now I am starting to introduce variations as to the way my test works. There are a few cases that I will only access part of the memory, and I will say, well, this string, if this string comes up, answer with this string. In other cases, I am running all the logic that the SQLite bank has. Well, look at this query, run all the business, find out how do I find this data within my tree structure that I have, and answer with that, right? All these things increase the level of what I'm testing. Now let's use it. I have my repository there. I was doing nothing, so let's do the NRL there, the Bitly or something like of the sort, and I use a short path there, very short, and then I get back a direction to some long address. For instance, Google something, 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 or DigitalOcean, create your droplet, and so on. Great, I then add this function to my server, and I say, well, to you access pathway slash s slash something with some any hexadecimal, and then you say, we can only use a 12-character hexadecimal, otherwise they'll say I know nothing. And then simply I go back to my database and I say, well, someone asked me to expand this URL 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. A and B. Um, and then, if I have no answer to this, I say, well, I know nothing about it. Go for. If I have any some answer for that, okay, I answer that with the found 302, uh, and I redirect it to the first string, right? Okay. Well, the part that really matters for us now is this expand URL, which is actually a function that I am adding to what I had called my repository object and saying, well, I can translate, given a string, I can translate another string. This issue of the context you're seeing there in CTX is a go, you can ignore it. It doesn't matter what we're doing now. All right, and then let's test this all. Test for invalid URL is it's easy. I don't have to do anything. Anything that I put there will work. So I can write the test and say whichever the dependence run. This you know this thing will run. I'm not using the bank, and my test doesn't have to change. The next thing is that I will test with an URL that is valid but has not been recorded. So I have those two characters, but I still don't know how to translate there. Same thing, since I didn't have to set up any data, this test will simply run. Okay. Now. Now is the problem because now I need to test if I have a valid URL, it will work. However, to do this, I need to do the setup. I need that to be recorded, right? And how do I do this? Well, if I am running with that sub that we had set up, I need to do the sub setup. If I'm running against my integration test, I need somehow to put that inside SQLite. And if I'm running with production systems, what then? Right? Well, somehow I need my production system to have this registered there. How do I solve this problem then? Well, just as we were solving everything else, I go there and I inject dependence on my test, which means that now my test needs to have access to this service dependence that I have in order to check and do the setup of whatever happened. Am I going too fast here for you guys? Well, let me see here. No, it's okay. Pace is okay. Well, anyhow, what happens then in my magical function that injects all the dependencies? Well, for those people who were doing the object test, it's easy then. We already had that sub that I had passed on to the server. The only thing I have to do now is to pass it to the test. But before I was passing a long list of things to the test. A list of things is hard, is boring because every time I change something, I have to change the signatures of my tests that were using it. So I will extract this object that will represent all the dependencies of my test. Okay, I can extract this test. That's a test dependence. I put everything that I may want to pass and use in some test. And then the only thing I do, I put those data inside this object. All right, so far so good. Very well. So now let's use this thing, and I will extract some functions here, and I will call this integration dependencies. And we call this smoke. You may call acceptance, whatever you want to call. But I will leave a function for each one because now it is very easy to know in which context I am. Now everyone needs to have access to the bank, so I add there in my test dependencies, key1, key and in each one of my dependencies there, my dependence functions, I pass the DB I have. For all of them, I practically already had, except for the integration for the smoke, the acceptance, where I don't know which was the connection, but I know which was the connection because that I passed to my real server. So now the only thing I'm saying is that my test always also needs to get this information if it is available. So I go there and I say open a connection +5 with the ByConnect address, which is the one I was using at the time of using the server, and then I do the same thing. The server has the same object that knows how to deal with database. I pass it on to my test, and it will be able to do all the queries that I need to do. Okay? All right. And now I need to do the data setup, and this is the part that I admit to you that is a bit ugly depending on how much data setup you need to do. Gotten is the system where I can say, well, you are of this type. If you are of this type, okay me, and return the variable with that time so that I can do some function calls. So the database dependencies I have, are they of the stub type? If it is, I am in a mocked environment. If I am, I can just go there and do a call that the stub has, but nobody else have. In my case, adding input 0 to 9 or AF or AB, I'm not sure, and I want to return the result, whichever it is. And then I can run this test. And I don't have the test output here, but you could get it, right? Basically, every time I have something to do, I think about my test with the system. My system, I can refactor the production one. Why don't I do the same thing with the test system? At the end of the day, your test is a system. You can use the same techniques, dependency injection, refactoring, object station, everything. You can use that in your test system. And this is what we do today there where I work. Well, Hugo, don't do this because it'll take a while. Acceptance test is slow. It is not in our case. So this is one of our uh, 22 services that my team maintains, and you can see that we have more or less 180 tests for this service. The number of digital code lines I have is higher than that of my true server, not by much. It is practically 1 to 1, and they run fast. The line you see there, number 7, is when I am running locally in my machine, and I run those where we saw there. You saw the local process. You make all the calls with it, and you take it back. And this runs in about a minute and 15. And the line down below is testing outside the DIO. In other words, I can test from my computer. I can test here at Agile Brazil, all our systems at DigitalOcean, the DO, running all these calls, and it takes a minute and 46 seconds. So our feedback time when we are developing, if I am to test the entire system, it takes at most 1 minute. If I am testing the entire system within production, it's 2 minutes. So we can use this single test suite to have a feedback at the time of running the development in your machine, which is all the functions that the test has, and the same test will run there, the introduction. What I gain here is that if you think of something that we say a lot about test is test coverage. Test coverage, like, well, it doesn't have to be 100% and that, but test coverage only runs in your machine, developer machine. This system runs a test coverage in your machine, in the pre-production, production, and it covers your code, that code of your friend and the code of the person that you've never met but used the library that they had developed. So with this, I can guarantee I have a lot of trust that when this thing runs, everything is working for my customers. Another thing that we have done that were great, since I am injecting a database, or the way the system talks with the database, we ran a SPI database version that SPI collects all the queries we will generate in our system when we run the test, and then we run all these queries with the explain in the database, and we identify things like, ish, I forgot an index, and now we'll run a scan in a table that has 5 million lines. This will be very, very slow. I can't even use a deploy. It fails before my system being put into production because my test said this is not going to work. You have to stop because you have some problem here. We also run this suite periodically or regularly, so you don't have to have a deploy, you don't have to have anything happening. I can only put a machine there every 10 minutes. It roots in the suite, the test suite against the production system, and with this I find things that have nothing to do with our code. I can guarantee, for instance, well, latency is increasing and we end up losing connection. I can find and see these things with the same test suite because it can run outside and inside, and I can identify at this point that the problem is outside and not inside because I can run it from inside and see that this one works. And the last thing we took as a benefit here is that, as a matter of fact, if you remember my previous example, I ran a trick there because I knew we wouldn't have enough time. I didn't solve how I do the data setup for real production. And then, well, we needed to solve this. What means is that my customers, they may test our API because we need to be able to test our API. So all the things you need to check whether your thing works or not, I have to make them available to everyone else. And this makes our API much easier to be used because customers themselves can run our test suite on their side to say, well, something changed here. It is not what I wanted. It is not working. And, fix bugs in their system. However, not everything is a shining day. There are other things that we wanted to do as well. So one of the things that we would like to do is that mock setup that I said that it's a bit ugly and boring because that is mocked and then run all these things. Well, it could also be used when I run it in production because once in production, the idea of the mock is that I am saying, well, when I don't have production, this is how production should behave, right? However, and here I have both information. I know what the production will run because I run it against the production, and I have what I thought the production would do. So I can detect it when my mock is no longer updated with the real behavior. We would like to do this because this is one of the largest problems we have with mocked stuff. We think it is right when in truth when you run it against the real system does not behave as the mock said it would behave, so the mock didn't catch the problem. Now, we also want to improve this part of database preparation. So this is what I was saying before. I will have to go there and generate the entire code, the database structure, and inject some data on the seed there. Well, this may happen in each one of the tests because the tests run alone, so this increases our time. If we can solve this problem, I believe that 1 minute that it takes us locally can drop down to maybe 10, 15 seconds. So we still want to work further on this. And also, one thing else I would like to is to try this in other contexts. We did this, it worked very well for us, but I wanted to understand whether this works with other people, other contexts, other languages, other frameworks. So in Rails, this is very difficult to do, but anyway, for other ones, this might be easier. All right, people, I know it is a very technical talk. I hope you're still awake, and I would very much to have your feedback on it. If you have any questions, criticism, complaints, I'll pass on the microphone here. or I can, repeat the question should it be needed. Hello. Well, I really liked your ideas. I'm not sure if I could apply all of those in my context, but some of them for sure, some very nice ideas. And I would like to ask you to comment on the fact that if this approach generated any impact. I don't know much about Go, or I'm not sure if it's possible, if it caused any impact on the way you do a TDD, or if you could do it with this kind of approach, and if generated an impact on the fault feedback, because if there is a fault, even if you're running, for example, the integration test, but you're running the same code or same code stretch, how can you have the feedback about it, and how do you deal with this? Congratulations on your talk, anyway. Thank you. Well, this absolutely impacted the way we work. Not did not prevent us to do TDD of in any way.
However, the manner by which TDD evolved, instead of begin doing the simplest thing I could, this part became more complicated because I want to do something that is a black box. I have to think as though I were not in the service. I cannot do this anymore. Well, you return one, so I'm going to say that you have to return one, and then I'll move on to the next small step just to say, well, now I have to return 10. So if I had inputs for that, fine. I can do that, but only at the macro level of the business. But since this is a microservice, I do not have many layers. So I'll have at the most 2 levels of objects. So I'm skipping one level, but I'll take the entire remainder of the TDD. The TDD has changed a bit because I will first run the unit test, that release. Well, use that, inject everything into the memory and etc. This is not always works out when you're running integration. So what it all boils down to is that I run that, I do my TDD a bit higher level with the unit testing, and then I run against it, then I say, well, oh hell, I didn't do the setup as I should. Have to do better. So I refactor the test, run it again, and so it goes. What happened is that we will held hostage of these tests. And when the test passes, we don't even look at it again. Just throw it to production. There's nothing on the way. I don't have to think anymore. I'll hold a manual test and so forth. No, that's about it. And the second part of your question was, in the case of failures, that depends at what level the failure happens. If it is failing at the unit level, do the same thing you would normally do. When it starts failing, well, integration is still easy because you can run everything locally. There's not much of a problem. And we also run local, however, externally. It is halfway between the two, where we have all our dependencies in the Docker, and then we have everything in my computer, however, in different processes. These things will capture many errors, but when we get to pre-production, this is where we get the worst. The good of pre-production we end up tackling are those things that I wouldn't have imagined testing because I didn't know that my dependents had that funny behavior. So sometimes we have our pipeline in the red when we're developing new things because we went in, we threw it in pre-production, think that everything would be all right, and then, no, that didn't happen. The dependence doesn't do what we thought it would do. So we have to backtrack and correct it in order to end it up. We have still 1 minute, folks. I'd love to talk to you. Let's do this at the lounge area in front of the mainframe corner where we have some open space. Okay? Thank you all.